When we solve a system of equations by graphing, we graph the two equations together on the same axes and look for their intersection point. In this example, we have two equations that are already written in slope-intercept form, so they should be relatively easy to graph. Our objective is going to be to graph them very carefully and make sure that we can find the intersection point. We'll begin by graphing the first equation, y equals 1/2 of x plus 2. So we started our intercept of 2, we follow our slope of 1 over 2. We have our next point at the point 2, 3. We connect those two dots, and we have our line. When we graph the second one, we're probably going to want to be a little bit more careful to make sure we're graphing with accuracy. Because we are looking for the intersection point, we want to make sure that we can find that intersection point and be able to see it on the graph. So it's one thing to say, I see that they intersect. It's another thing to say, I see where they intersect. So we want to be very careful when drawing this next line. We're going to start at its intercept of 5, and we're going to follow its slope of -1 over 1. So we're going to go down 1 and right 1. And you'll notice that if I go down 1 and right 1 more, I end up right on top of that point that was on the red line. That is at the point 2, 3. And as I continue the blue line going in both directions forever and forever, putting arrows on the two ends, that is the only location where the red and the blue are going to intersect. We do not have a situation where the lines are parallel. In the case where the lines are parallel, we have no intersections. And we don't have a situation where the lines are identical to each other. That's what's called coincidental lines. That would be an infinite number of solutions. Here we have just two lines with different slopes and different intercepts intersecting in one location. Now you can already start to see where this strategy is a little bit problematic. We got lucky that we intersected at a really nice point 2, 3. And using a graphing technology, you can see that point very obviously. And that point comes out, jumps out at you. You can click on it if you're using Desmos to view your graphs. But if you're drawing them by hand, it's much more challenging in a lot of cases to ascertain where that point is, unless it falls perfectly on a really nice coordinate, something that's really obvious, like we had in this situation. So we are going to embrace a little bit more of a technological approach when it comes to graphing instead of doing it by hand, because if we do it by hand, we're susceptible to more mistakes, and it's really hard to determine where those points are because it is incredibly difficult to draw lines accurately with the exact correct slopes, and then being able to determine maybe those in-between locations that are harder to see.